Good day once again. In this class, we'll be talking about and working on a topic which is indices. And from the note given, an index, which is the singular of indices, is a number of times its base can be used as a factor. When a factor is a number which can be multiplied together, that is the definition for a factor. A factor is just a number which you can multiply together. So the plural of index and factors are indices and factor respectively. So though that is just an illustration or uh, introduction to indices. So as illustration given, you can see that a number is being multiplied 4 times. That is a times a times a times a, which is now written as what? As a raised to power 4. So here, that 4 is called what? Is called index. While the a is called base. And the factor is also 2, which is also the same thing as base. So as per example given above, you can then say that what? Base, which can also be called factor, is a, and the index is what? Is 4. Thus, from this illustration here, our a is called base, while at the n, that is a raised to power n, the n at the superscript is called index, where a is called what? The base, as I've said earlier, and n is the index. So index can also be called power or exponent. That is another name in which you can call index. Now, with the illustration given above, we now work on laws that must be followed when solving indices problems. So, and the laws are, the first one we'll be working on is multiplication law. So, this law helps us to solve indices problem of some base, of same base but different powers. Sometimes it can be of the same power actually, when multiplying their base together. So that is the illustration when we talk about multiplication law. You can see that ax multiplied by ay, in which the index of that base can be what? Can be x and also y, in which x and y can also be equal, in which the index of that same base can actually be the same or different. But one thing about multiplication law is that whenever you are multiplying same base with, let's say, same index or different index, the alternative will be what? Will be a raised to power the sum of the what? The sum of the index. So let's look at this just simple illustration. We are asked to simplify 2 raised to power 5 multiplied by 2 raised to power 3. Once you are seeing multiplication sign in between, that means you are going to apply what? Multiplication law. So normally the above can be solved in the below format. You can solve it in this way, in the normal format that we are familiar with. That is, 2 raised to power 5 multiplied by 2 raised to power 3 will be what? That raised to power 5 is telling you that the number of times you are multiplying 2 with each other. So which is what? 5 times. That is 2 times 2 times 2 times 2 times 2 times 2. So, and 2 raised to power 3 is what? 2 times 2 times 2 times 2. So, and if you see that 2 times 2 times 2 is going to give us 8, and another 2 times 2 times 2 is going to give us 8, and 2 times 2 is going to give us 4. That is why we are having what? 8 times 8 multiplied by 4. And eventually, the answer is what? 256. But you don't need to be wasting much of our ink or much of our time. You don't need to be stressing ourselves. That is why the law is being what? Is being introduced. So, note, indices are used to avoid repeating a factor or base, which may later cause confusion or mistake during our work, and they generally faster than multiplying the factor one by one. That is just the basic benefit in in applying indices, especially using law of indices. So it's reduce the stress of what, of repeating numbers and to avoid confusion at the long run. So that is why you must apply all these laws and you must be using it. So we apply the law of indices now. Let's approach the question using multiplication law. We are using multiplication law because what, the multiplication sign is in between the what, the uh the base and the in index. So now let's apply multiplication law. So solution 2 raised to power 5 multiplied by 2 raised to power 3 is just simple. Apply the multiplication law. It's now what? It implies that what, 2 raised to power 5 plus 3, which is 2 raised to power 8. And if you press 2 raised to power 8 on your calculator, is what? 256. See how fast it is. So now let's look at example 1. You have to simplify 2 raised to power minus 3 multiplied by 2 raised to power minus 1 multiplied by 6 raised to power 2. Don't be scared. It's very simple. So and the solution is that what? Consider the equation equals to what? 2 raised to power 3 multiplied by 3 raised to power minus 1 multiplied by. Recall 2 times 3 will definitely give us what? 6. So you can write that 6 as what? 2 times 3 in parentheses, everything raised to power what? Power 2. So which also implies that what? Can see from here implies that what? 2 raised to power minus 3 multiplied by 3 raised to power minus 1. You can see that we've multiplied the index with everything inside the parentheses. That is called product law, and we are soon going to read there actually. So don't be panicked, just be patient. We are still going to get there. So which is what? 3 raised to power minus 1 multiplied by 2 raised to power 2 multiplied by 3 raised to power 2. So apply multiplication law now. Before you apply multiplication law, you need to what? You need to collect the like base. Yeah, you need to collect the like base. You can see here we are having two different base, which are what? 2 and 3. So you need to collect them together before what? Before applying multiplication law. So after collecting them together, you deduce that we are adding up the base of what? The base of 2, which is minus, you can see at the left hand side here, we have 2 raised to power minus 3 multiplied by 3 raised to power minus 1 multiplied by 2 raised to power 2 multiplied by 3 raised to power 2. So and in the right hand side, you can see that we have what? We have 2 raised to power minus 3 plus 2 multiplied by 3 raised to power minus 1 plus 2. Yeah. So which means that what? Minus 3 plus 2 is definitely what? Minus 1. That is why you are having here that what? You are having 2 minus 1 multiplied by 2 raised to power minus 1 rather multiplied by 3 raised to power minus 1. Anything raised to power, 3 raised to power 1. And anything raised to power 1 is what? We give you that same what? That same base. So that is why you are seeing in the less after that line, that is 1 over 2 multiplied by 3 over 1, which implies that what? 3 over 2. Recall, 2 minus 1 is called negative index, which is what? Will give you 1 over 2. That is a fraction. So can check through. So now thus the final answer or the final simplification of 2 raised to power minus 3 multiplied by 3 raised to power minus 1 multiplied by 6 raised to power 2 is what? Is 3 over 2. So can go through. I'm just going to give you like 1 minute to go through. You can see the solution here. The video you can zoom in to have better view. So do you see now? So that is it. That is the solution for that question 1. So now let's move to question 2. The question 2 says that you should simplify 5y raised to power 3 multiplied by 2y raised to power 6 multiplied by what? Y raised to power minus 1. And the solution is this. So the first thing is that what? You collect the what? You collect the like times. That is why you can see the normal one without an index, which is 5, 2. So that is why you're having 5 multiplied by 2. Then we also collect the what? The one with index. That is y. And they are having what? Same base. So which is 5 multiplied by 2 multiplied by what? Multiplied by y raised to power 3 multiplied by y raised to power 6 multiplied by what? Y raised to power minus 1. So, and we have what? From there, we have 10 because 5 times 2 is what? It's definitely 10. So we have 10 multiplied by y. So once you are saying multiplication in between, definitely you are going to add all the what? All the indices. So that is why you are having 3 plus 6 minus 1. And which is going to give you what? 3 plus 6 minus 1 is what? Is 8. So that is why you are saying 10 y raised to power 3 plus 5. And eventually here we are having what? We are having 10 raised to power 10 multiplied by y raised to power 8. And that is our what? That is our final answer. Don't mind this one. The final answer is 10 raised to power 10 multiplied by y raised to power 8. I think that is typo error, typographical error. So that is the solution for that one. That is the simplification of 5 y raised to power 3 multiplied by 2 y raised to power 6 multiplied by y raised to power minus 1, which is what? Which is 10 multiplied by y raised to power 8. That is the answer there. So the next one is you are asked to simplify q raised to, you can see this one they are having constant base, so you don't need to stress yourself. Just do what? And multiplication is existing in between. Just add up the what? The indices. So you can see here that what? We're adding up the indices. Record, whenever you have ordinary number, that also is telling you that what? Is also raised to power 1. So that is why you are seeing one that is not feasible before. That is just those. Where did you see this one? It's already there, but we make it infeasible. Because there cannot be writing q raised to power 1. No. So that's why you're adding up what? That's why it's equivalent to what? Q raised to power 0 plus 1 minus 6. And that is what? That is q raised to power minus 5. And recall, I told you, whenever you are having a negative index, that will be what? The expression will later be what? 1 over the what? 1 over q5. So which means q raised to power minus 5 is what? 1 over q5. So therefore the solution for this, or the simplification for this question given is what? 1 over q raised to power 5. You can do it the normal way to cancel out blah blah, you get same answer. Yeah. So which example is this? This is example 3. Let me just zoom out so that you can have a better preview. So you can see that is the solution for 2 and 3. So let's go to division law now. So division law is just the same thing. Whenever you are dealing with multiplication law, we do what? We add. And whenever we're dealing with division, we do what? We subtract. So this is when a raised to power x is dividing a raised to power y, which can also be expressed as well, which is also equivalent to a raised to power x minus y. Do you get it now? So whenever you see division, you what? You subtract the indices from each other. So let's see the example relating to this second law, division law. So you have to simplify m raised to power 6 divided by m raised to power 3 divided by m. And the solution is what? The expression is equivalent to, once you are seeing division in between, just be deducting, be subtracting. So that is why m raised to power what? 6 minus 3 minus 1, which eventually give you what? M raised to power 4. Simple. That is the answer. So the next one is simplify what? 10 raised to power 15 divided by 10 raised to power 6. You can see they are having constant base. Divided by 10 raised to power 4 divided by 10 raised to power 2. So you do what? Subtract. So that is why everything is equivalent to what? Is equivalent to 10 raised to power 15 minus 6 minus 4 minus 2, which is what? 10 raised to power 15 minus 12, which is what? 10 raised to power 3. So that is the answer. Let me just zoom out this. Example 1 and example 2 regarding their division law. So let's move to example 3. So you can see this one, I put a note there before simplifying, because we're having ordinary number and the number or letter with indices. So and you are asked to simplify it. That is 5 s squared multiplied by 3 raised to power minus 1 multiplied by x raised to power minus 3 divided by 5 raised to power minus 1x. So before simplifying this kind of equation, like I've said earlier, you do what? You must collect the like base. That is it. The like base. That is like times. You collect the base, the one that is the same. So that is why we are having what? We are having The first expression is you collect the like base, and that is why we are connecting ordinary number with what? We are separating it from letters now. So that is why we have 5 multiplied by 3 raised to power minus 1 divided by 5 raised to power minus 1 into parentheses, recall. Also into parentheses, x squared multiplied by 3 raised to power minus 3 be x raised to power minus 3 divided by x. Also in parentheses, both closed by what? By curl brace. So you can now deduce here that if you observe that now we've collected 5, 2 together because they are of the same base. I've moved 3 away from 5 now. Can you see from here? Yeah. So that is why you're having 5 divided by 5 raised to power minus 1 multiplied by 3 raised to power minus 1. Now you see that we've automatically what? Expressed because they are having like base. We've introduced division law into these x raised to the power of its indices. So that's why you're having x multiplied by x raised to power 2 minus 3 plus 1. So and you can see now 5, because it's in division form now, we apply division law. That is why it's now raised to what? 5 raised to power 1 minus 1 multiplied by 3 raised to power minus 1 multiplied by 2 minus 2, because 2 minus 3 plus 1 is what? Is minus 2. That is why you are having multiplied by s raised to power 2 minus 2. And 5 raised to power 1 minus 1 is 0. That because 1 minus 1 is 0. So 5 raised to power 0 is 1. That is 0 index. Anything raised to power 0 will definitely what? Give you 1. Yeah. So that is why we are now having at the last step that what? 5 raised to power 0 multiplied by 3 raised to power minus 1 multiplied by x raised to power 0, which is telling you that 5 raised to power 0 and x raised to power 0 is what? Is 1. So that is why you are saying in this expression that what? 1 multiplied by 1 raised to 1 over 3, because recall now 3 raised to power minus 1 is what? Is also the same thing as 1 raised to power 3. Is called negative index. So multiply by 1, which eventually give you what? 1 over 3. And what I've been saying, this is it. Whenever you have x raised to power 0 is 1, anything raised to power 0 is 1. We call it 0 index. And any raised to power minus 1 will be what? Will 1 over of that base and that power. So you get now. So we call it negative index. Let me just zoom out again so that you can view it very well. So that is the solution to example 3. That is how to simplify example 3. And next thing we go to product law. Don't worry. Don't feel as if it's simple when you have the better understanding of it. And after this, I see stuff like 9 to 10 questions for you to have more knowledge on the topic called indices, so that whenever you see indices, you won't be funny, this topic is too complex. No, it's very simple. Once you have the understanding, no wahala. So product law, this can be applied as what? Whenever you have the expression so that a base and its index is being put inside the parentheses and being raised to another index again, that is when your mind must cut across what? Must go straight to what? Product law. Recall that the one we've been doing, actually I've made mention of we've applied product law in some question, but majorly is when the base and the index is being multiplied by the same base with different index directly, not in parentheses now. But when a base and the index is inside a parenthesis and being multiplied by another parenthesis, what will you do? Or same parenthesis, same index, what are you going to do? You apply what? You apply product law. So that is why you are seeing this expression is what? You can see that a raised to power m inside parentheses, all raised to power what? Power n is now eventually what? A raised to power m times n or mn, all the same. So let's look at some examples regarding this law. We are now treating the third law. So you have to simplify parentheses 2 raised to power 3 or let me say open bracket 2 raised to power 3 close bracket everything raised to power 2. What will come to your mind is what? Is product law. So 2 parentheses 2 raised to power 3 multiplied by index of 2 is what? Is now what? 2 inside the parentheses or everything multiplied by what? 2 times 3, which is what? Which is 2 raised to power 6, which is 64. That is telling you that after multiplying 3 times, it's still being square. Shey you get now? That is just the simple illustration. So the answer is what? It's 64. So let's look at this one too. We have to simplify into open bracket minus 2 x raised to power 3 close bracket everything raised to power 4. You can see that we are having a negative number there. Don't be panic. You solve it stepwisely. So the solution is this, the simplification is this. You see that I've separated normal number from the actually everything has its own index. I've separated ordinary number from letters now. Yeah, because you need to collect the what? The like times. So now after doing that, you can see that I've put minus 2 into one parenthesis and x into another parenthesis. So now open bracket minus 2 close bracket everything raised to power 4 multiplied by parenthesis x raised to power 3 everything raised to power 4. Now look at this note. You must decode this note. You must master it. You must learn it. You must grab it. You get what I'm saying now? Note, when a negative base has a negative base has index of even number, either positive or negative index. Shall you get now? Either positive or what? Negative index. The final answer will always be what? Will always be positive. Will always be what? Will always be positive value. Yeah. So let me read it again. When a negative base has index of even number, listen, even number, either the index is what? Is positive. Forget if it is positive or negative. The main focus should be what? Should be even number. When this is when we are dealing with what? Negative base. Now you know that what you have been solving since is on what? Is on positive base. Now we are now working with negative. This is where because anything involving negative you must be careful so that need debt so that you won't be a debtor. Say again now, you won't make mistake. Positive is something easy to manage, but negative thing is very complex indeed. If you are not careful enough, you are going to go to a wrong way or get wrong answer. So that's why I'm giving you these notes now, this keynote. When a negative base has index of even number, either positive or negative index, the final answer will always be what? Positive. That is, when you are having a negative base into a parenthesis and everything is to power n, either it is what? If either your n is what? Positive or negative. Now let's concern about that. But the main thing is once your base is negative and your index is positive, is even number, definitely you are going to get what? You are going to get a positive result, positive number. So your final answer, this expression here, you can see a n or minus n inside a parenthesis, everything raised to power minus n. I'm just trying to prove to you that you are definitely going to get the same answer. This is when you are having a positive. Yeah, this is when your n is positive. Yeah, you see that everything is going to give you a positive answer when your base is negative and your n is positive. So definitely you have a raised to power n. And when your base is negative and your n is also negative, it's going to give you fraction. That is when you come across what? Negative index. But the main thing is before you can get a positive answer, your index must be what? Even number. That is all about even number and negative base. So also when a negative base has an index of odd number, now you are going to get what? You are going to get either your index is positive or negative. You are going to get negative answer. So if your index is positive, definitely you won't get fraction. But if your index is not negative, forget either odd, you are going to get fraction because it's going to give you a negative index. So you get now, you apply negative index rule. So you get fraction and what? A negative answer. So you get now, that means the sign will not change for the base. Do you get what I'm saying now? But if it is even number and when your base is negative, you get positive answer. Either fraction or in whole number. So you get now. And when your base is negative and your index is odd number, you get what? You get negative answer. So let's now solve this question now. Yeah, let's solve this question now. So with that rules, you can see that minus 2 inside the parentheses, everything raised to power 4 is now giving what? 2 raised to power 4. It's just like minus 2 multiplied by minus 2 multiplied by minus 2 multiplied by minus 2. Minus will cancel minus, minus will cancel minus. That is why we are having 2 raised to power 4. Shall you get now? So that means minus 2 everything raised to power 4 will definitely give you a positive value, which is 2 raised to power 4. And x raised to power 3 inside parentheses everything raised to power 4 is what? Is now you apply what? You apply product. That is why you have 2 raised to power 4 multiplied by x inside parentheses everything raised to power 3 multiplied by 4, which eventually is what? 16 x raised to power 12. Final answer. So your final answer for this expression is what? 16 x raised to power 12. So let's solve the third example. Don't be panic. So you see that we are now been applying multiplication law, division law, and what? And product law. So let me just, this is the solution for the question 2, and we are moving into, can zoom in, this question 3. Question 3, see, can write it down if you like. This question 3, before I zoom in, look at it very well. So let me just zoom in to have better view of the solution. So you can see here that the solution for that question you have to simplify, which is what? Minus y raised to power 5 inside parentheses everything raised to power 2 divided by also minus y raised to power 2 everything in parentheses which is raised to power 3. So if you're having that kind of expression for this question, so what is the solution? The solution is what? Recall that the power of y is what? They are having same negative base now, but the index is what? Their index, let me say their indices are what? Are different. One is 5 and one is 2. Which means though it's a positive what? It's a positive index for that 5. But is what? Is odd number. So definitely we are going to get a negative answer. So, but before then we apply Bodmer's rule. Actually, you must first apply product rule before solving. Yeah, you apply Bodmer's rule because you open the bracket first before what. So now, actually, if you apply same thing, you get same answer. Actually, yeah, that is just the bitter truth. You get same answer. So now, which imply that minus 1 inside parentheses everything raised to what? Everything raised to power 5 times 2. Everything raised to power 5 times 2. You see that we've applied product law or product rule divided by what? The same thing. Minus 1 inside parentheses everything raised to power 2 times 3. So we now have what? We now have open bracket minus y close bracket raised to power 10 divided by open bracket minus y close bracket raised to power 6. And because both power for that minus y base is what? Both indices are what? Are even numbers and positive. You definitely have what? Positive value. So that is why this expression is now what? Is now okay. You can now see that we are applying division rules now. Actually, you can solve directly from that place because everything, this one can be what? You can be y raised to power 10 because the 10 is even number divided by y raised to power 6, you get the same thing. And when you apply y raised to power 10 divided by y raised to power 6, applying division law or division rule, you have what? Y raised to power 10 minus 6, which is y raised to power 4, all the same. And we can still follow this process. Minus 1 inside parentheses 10 raised to power minus y inside parentheses, inside the parentheses everything raised to power 10 divided by minus y inside parentheses everything raised to power 6. Applying division law, that is what? That is minus y inside parentheses everything raised to power 10 minus 6, which is division law. So eventually we have what? Minus y inside parentheses everything raised to power 4, which is what? y raised to power 4. So that is the answer there. Y raised to power 4. So the expression or the simplification of this minus y raised to power 5 inside parentheses all raised to power 2 divided by minus y raised to power 2 inside parentheses all raised to power 3 will be what? Y raised to power 4. Just follow the rules and you won't have problem. So this is question 4. See the solution before I zoom in. I'll zoom out to check the solution before I explain how it's been done. So now let me explain. So you can see that 5 raised to power 4n minus 3 multiplied by 125 raised to power 2 minus n. So, and you can see that we are having 5 raised to power 4n minus 3 multiplied by 5 raised to power 3 in parentheses, everything raised to 2 minus n. You'll be wondering now, 125 changed to 5 raised to power 3 is being expressed at this right hand side after that dot, 3 dot. That is 125, if you convert it to index, is what? 5 raised to power 3. So that is 5 times 5 times 5 is going to give you 125. So then after that you multiply what is, and then you will deduce that, or observe that 5 raised to power 4n minus 3 multiplied by, you can see that we've taken out the 3 inside the parentheses, the index 3 which is inside the parentheses, you brought it out. Now it's multiplying the index which is 2 minus n. What did you do there? What did we do there? Is what? Is product law. So we recall product law. I've explained product law, and we are still working on product law actually. So that is why we have a multiplied by 5 all raised to power 3 into parentheses 2 minus n. So if you open the bracket, you have what? From here, you can open the bracket or you just add it up. So from here we apply multiplication law. You can see that after, once they have the same base, apply multiplication law. That is what? That is why we are having 5 raised to power 4n minus 3 plus 3 into parentheses 2 minus n. So which is equal to what? Open the multiplying 3 with what is inside the parentheses. We have what? 5 raised to power 4n minus 3 plus 6 minus 3n. So you collect the like times with respect to the indices now. What is at the top? The power. So that is why we are having 5 raised to power 4n minus 3n minus 3 plus 6. And eventually we have 5 raised to power n plus 3. So that is the answer. And you can simplify for that. 5 raised to power n plus 3, you can split from what you understand the multiplication law. You reverse it. So that's why you're having 5 raised. The expression for 5 raised to power n plus 3 can also be written as well. 5n multiplied by 5 raised to power 3. So 5 raised to power n multiplied by 5 raised to power 3, we call 5 raised to power 3 is what? It's 125 multiplied by 5 raised to power n. And the final answer is, you can leave it like this and you can put it in the final answer, which is 125 into parentheses 5 raised to power n. So that is the solution for that. So, and we move to example 5. Recall that now we are asked to simplify minus 2 raised to power 0 multiplied by minus 2 raised to power minus 3, everything raised to power minus 2. Recall that x raised to power 0 is 1. So automatically minus 2 raised to power 0 is 1. So you don't need to stress. So we are left with what? We are left with 1 multiplied by parentheses minus 2 all raised to power minus 3 and everything raised to power minus 2. So recall 1 will always be the same. You bring out the applying product law, you bring out the minus 3, you bring it out, you multiply it with what? Minus 2. That is why you have 1 multiplied by parentheses minus 2, everything raised to power minus 3 times minus 2. So that is product law, and which is give you minus 3 times minus 2 is definitely give you 6. That is why we are having 1 times minus 2 raised to power 6. And I told you, once the index is even number, definitely the final answer will be what? Will be positive. So once the I don't know, the has been written, once the index of the negative base is even number, so minus 2 raised to power 6 will be what? 2 raised to power 6. They are the same thing. So which is what? 64. Simple. So I'll zoom out again, just check through. Check the solution. And we go to question 6. You have to simplify. Inside the parentheses is what? Minus 3 y raised to power 3 all raised to power minus 1 multiplied by inside the parentheses minus 6 y raised to power 4 everything raised to power 3. So the first thing is that what? You apply product what? Product law. Yeah. So applying product law, we are having expression as what? 3 minus 3 raised to power minus 1 multiplied by open bracket y raised to power 3 close bracket everything raised to power minus 1. The same thing to the other one, that is multiplied by minus 6